This video covers Monday, topic 7-6. I'm sorry that I'm out again. It's yet another training that I'm being told I have to go to, but I promise you I will be there tomorrow. Even if I'm like on my deathbed, I will be there because I feel so bad I've missed all of this. That being said, any stamps that you are missing for 7-1 through 7-6, 7-6 is what we're doing today. So 7-1 through 7-6. Any of those stamps that you are missing, I'm going to take for a, hey, you did it. I don't care that it's late because I need you to make sure that you've practiced. Also, if you've done all of them, you have your 5 stamps already, 5th one being the one that you got today, and you're ready to move on, then you might want to go back and do a quick review of the stuff that we talked about, basically, before the break, just so that you're ready for your quiz that is tomorrow. So you do have a quiz tomorrow, and I will take all late homeworks for no penalty tomorrow, as long as you get them to me tomorrow before class starts, or like when class is starting, okay? So if you have your 7-5, go ahead and check. This is 1 through 6. Sub, please pause the video for people to check their work. This is 7 through 12. Sub, please pause the video for people to check. If you're having trouble, please make sure you talk to a neighbor and ask them maybe to explain something to you. And now we are going to do our notes for 7-6. So these are notes from the packet you should have had from the week before Thanksgiving break. And we're continuing. So 7-6 looks like this: parallel lines and proportional parts and triangles. I have left some extra notes packets if you need one because you lost yours. If you lost yours, that means you have 1 through 5 to catch up on before Wednesday of this week. Sorry, my dog wants to be part of the conversation. So in 7-6, we have parallel lines and proportional parts in triangles. We're talking about the triangle proportionality theorem. So if a line is parallel to one side of a triangle and intersects the other 2 sides at 2 distinct points, then it separates these sides into segments that are proportional lengths, blah, blah, blah. So here's what it really means. If you're looking, we have these 2 triangles. Now, again, it helps if you will redraw the triangles. I've said that a couple times on a couple of separate things. So I drew the smaller triangle, and then the bigger triangle is CAE with 4 and 3. So the red triangle goes all the way out. The blue triangle is the smaller one. So we are looking at these sides of proportionality. So CB is similar to CA. So CD would be similar to CE on the bigger triangle. Again, we're talking about proportions. So if you can kind of figure out what proportions they've set up, then things will be easier for you. So like CB and CD are in the blue triangle. CA and CE are in the red triangle. CB and CA are the left side, and this is the right side. So remember, you can set up your proportions however you want as long as you stay consistent. So if you're struggling with these, maybe try to figure out what have they done in these triangles. How did they set up the proportions? So in the next one, let me erase the green real quick. Nope. This is awesome. So awesome. Did you guys have a good Thanksgiving break? I hope you did. Mine was okay. Thanks for asking. Okay, so CB over here and BA. So that's this little piece. So this one would be a little bit better on the big triangle, huh? So on the big triangle, we have CB to BA down here. So this is the blue triangle, and this is like the extra part of the triangle. So CB to CB and BA are on the left side. And then we're talking about CD. So big piece on the top would be congruent to little piece on the bottom. And that is the right side. So we're just setting up proportions on these problems. Okay, the next one, if I still look at this big piece, because I see CA and BA. So BA down here to CA, so this full piece, so left side, and this is part and big triangle. So you could say the red one since we drew the red one earlier if you wanted. So DE down here, little piece would be congruent to this big piece, CE, and that's on the right side. So we have lots of little pieces going on. We have like side and side. We have the top triangle and the extra part. We have the little part and the whole triangle. We have lots of different pieces going on. So the thing to do here is to color code or to redraw your pictures to make sure what you're seeing makes sense. Okay, and I keep erasing because I have that ability. One thing you could do would be to get a piece of scratch paper. There's some extra notebook paper around my room. And you could just keep redrawing these triangles over and over so that you can color code and label. So BA is this small piece to DE. So that's the other small piece. So small is actually on the top. So these are small pieces. This one was on the left side. This one's on the right side. CA is the full piece on the left side, so the full piece on the right side would be CE. So again, if you can label and figure out what they're talking about, especially if you can label your proportions, it will help you out. So when we're setting these examples up, example 1, to find the value of x, there's a couple different ways to do it. I, of course, want to show you the easiest way. So we have x on this side is related to 8 on the other side. Then we have a tiny little 1 that's on the left side and a 2 that's on the right side. So this is my left side and my right side. And this is like top and bottom. Now, as we talked about before Thanksgiving, I know it's been a little bit, but you can set these proportions up differently as long as when you cross multiply, you get the same thing. So if you did like x is to 1 as 8 is to 2, that's fine because when you cross multiply, you would get the same things. So just make sure when we cross multiply, you have the same things. If you don't multiply to get the same things, then that's where you have an issue. So when I cross multiply, 2 times x and 1 times 8. So if you do not get those two pieces, then your proportion is not correct. When I divide by 2, oh sorry, I just realized you guys said no yellow. When I divide by 2, x equals 4. Please don't scream at the sub because I used yellow. I'm sorry, I forgot. Okay. For this one, because I have two x's here, I want to make sure I put them on the same side. Otherwise, I'm going to have to do some serious factoring. So this one, I'm going to do a left side and a right side to make sure I don't end up with x's on the same piece. I can see I have a left side and a right side and then like a top and a bottom. So I'll do top and bottom. So the left side top is x plus 1, left side bottom is x. Right side top is 6, bottom right is 4. Now what I'm telling you is if you set these up the same way we did example 1, top to top, bottom to bottom, oh no, you'd be fine. Sorry, you could still do that. If you end up cross multiplying and getting x times x, then you've set it up wrong. I apologize. It's still my weekend. So I'm going to cross multiply 6 times x. Remember, we use parentheses here, 4 times x plus 1. So to bring this up, 6 times x is 6x. Distribute that 4 times x, 4 times 1. If you do not distribute, then you have not multiplied all of the bottom by all of the top, and you are wrong. So make sure you follow these steps exactly like I'm telling you. From here, we would move 4x because we're trying to solve for x. So 2x equals 4. Divide by 2, and x equals 2. Whoa. Oh, man. Sorry, guys. I don't know what's happening on this thing. I was trying to change the yellow color. Oh, well. Sorry. I'll do later. Okay. So a couple more examples. Here they tell me something that's not labeled. If RT equals 10, so this full thing equals 10, find the values of x and y. So the first thing I know, or that I could find, is y, because this piece plus this piece has to equal this whole piece. So 6 and y added together have to equal 10. So if I solve for y, then y equals 4. Now I can set up my proportion. I have a left side, a right side, a top, and a bottom. So if I'm looking at this, like this is the top, I guess. So left top is 4, left bottom is 6, right top is 2x minus 1, and right bottom is 9. Remember, you can set these up differently as long as we have similar proportions going on. And if you needed to redraw it so that you could see the top, then you could do that as well. And it would be like this, and you could fill in your missing pieces from there. So when I cross multiply, 4 times 9, 6 times 2x minus 1, distribute the 6, so 12x minus 6, add 6 to both sides, so 42 equals 12x, and divide by 12 to finish with x equaling 3.5. Okay, so basically just more setting up proportions and solving. Okay, now we can also go the other way, or the converse of this theorem. If a line intersects two sides of a triangle and separates, then the line is parallel. So here they're trying to ask us, using proportions, are these lines parallel? So the reason we could set up all those proportions earlier was because the lines were parallel. So now we have to set up proportions and see if they match. So E to G, this piece right here is 15. E to H right here is 5. L to G is 12. F to L is 6. So one thing I can deduce that they did not tell me, if this full thing is 15 and 5 is already being used, then this piece must be 10. So now I'm going to see, does the right side match with the left side? So top is 10, bottom is 5 on the left side. The right side, top is 12, bottom is 6. Well, 10 divided by 5 is 2. 12 divided by 6 is 2. So these are proportional. So we would say yes, HL is parallel to EF, because that's what they were actually asking. So Cliff Notes version, if the lines are parallel, the proportions should match. If the proportions match, then the lines are parallel. So it works both ways. Up at the top, I didn't make a big point about it, but the lines are parallel, so we can set up the proportions. Here, we're setting up the proportions to see if the lines are parallel. So, example 5, A to C is 30, A to E is 22, A to D is 10, and E to B is x plus 4. So the first thing I need to do is figure out what this piece is going to be, because I can't set up a proportion without the 4 pieces. So if the full thing is 30 And 10 is already taken. 30 minus 10 is 20 for this missing piece. Now they want us to find x so that these lines would be parallel. If they would be parallel, then their proportions would be consistent. So, top left, again, you can make the top anything you want, but top left 22, bottom left x plus 4, top right 10, bottom right 20. So I would cross multiply 22 times 20 and 10 times x plus 4. Distribute that 10. So 10x plus 40 equals 440. Subtract 40. So 400 equals 10x. Divide by 10, and x equals 40. So if x is 40, then those lines would be parallel. So parallel lines, set up proportions. If they want to know parallel lines, set up proportions and see if the proportions work. Or if they want to ensure those lines are parallel, then the proportions need to work as well. The other pages, because on these other pages, they have they don't have the tick mark. So one last piece. So they're telling us here that if you have endpoints that are the midpoints of two sides of a triangle that is parallel to the third, then the length is half the length of the third side. So here we have two things that are congruent. So like these pieces based on the tick marks are congruent. That's the first piece. So I can find the value of y. So that's, remember, a midpoint cuts it into two equal parts. So these two parts are equal. So 4y plus 6 would be equal to 2y plus 18. And I could find that value of y. So I subtract. So because that is a midpoint, and I know it's a midpoint because these two ticks mean that they are congruent, I can set the two ticks equal to each other. Now, the second part of that is if you have, this is kind of worded weird, but this piece is the other piece that you need. The length is half the length of the third side. So this is half of this length. So they are related. Now the easiest thing to do is take the smaller one and multiply it by 2. So we're going to take 2 of the middle and set it equal to the bigger. So 2 times the middle line equals the bigger line. And note, these two do not have ticks. So if we had these two ticks, those two sets of two ticks would be congruent to each other. So we have congruent, congruent, and then half as big or twice as big, however you need to think about it. So for this part in the blue to solve, I would distribute the 2. So 8x minus 10 equals x plus 11. And then go ahead and solve. So subtract x. Add 10. And divide to find that x equals 3. Okay, so we're going to do one more example to show you what I'm talking about. Notice these pictures look different than the pictures. So these are different because they don't have the tick marks on them. So the ones with the ticks are congruent. I suggest starting there. So 2y plus 18 is congruent to 5y minus 3. So they're congruent because of the tick marks, so I'll solve. So move 2y. Move 3. and y equals 7. The midpoint part says that this piece is half of the big piece, or the smaller piece times 2 would equal the big piece. So the smaller piece is at 5x minus 2, and 2 of those should equal 1 of the big piece. So I will solve. And find that x is 7.6. So you have the rest of class to work on your assignment 7.6 that you picked up on the way in. Remember that A7.1 through 7.6 will be accepted tomorrow for no late penalties. Also, remember that you have a quiz tomorrow in class, so make sure you've looked over all of those, 7.1, 7.2, 7.3, 7.4, 7.5, and 7.6. Make sure they're all done. If not, get them done today or tonight or tomorrow morning. And then make sure you bring them all, and that if they are done, that you've reviewed them for your quiz tomorrow. See you guys then.